Can you hear me? Good, won't bother talking then. This is the talk you actually want to see. Unfortunately, I can't give it because I don't understand it, but it's a really, really amazing paper on why we should measure, why we should share data. It's a brilliant talk. So download this and look at it while I'm talking because it's much better value. So I work for a regional internet registry. We're here to help you. The regional model is really quite strange. The UN thinks that Asia includes the stands, but according to the RIR model, you guys have the stands and we're a lot smaller. But there are compensations. So we developed a system that runs every day, and it's running somewhere close to 1 million now. These are a bit out of date. Experiments every single day worldwide on a budget of about $200 a day. And we think we can scale this up to about 8 to 10 million samples a day. And we're measuring things like capabilities in V6 and DNS, large packets, tunnels. We've been working on this for a long time. We were hoping to get on to doing some TLS stuff this year, but we haven't got there quite yet. So the reason we're doing this, well, there are 3 things about the network that are really important. There's the routing architecture, there's the name to address map, and there's the assignment of the addresses. Well, we do that bottom one. And there are some fairly open questions about this trinity of behaviors because there's kind of a dynamic tension between these things. So if you try and do something in routing, it's absolutely implicit that it depends upon the uniqueness properties of the address. There's no point trying to route your packets if it turns out that the addresses are with someone else, right? They're going to go in 2 separate directions. So the whole hierarchical model of address allocation is fairly implicit in what we're trying to do in routing. If you want to say things about names, you're implicitly assuming there's a global routing model so that if you give the name, someone can find it. And that depends on the unique addresses too. So there's interrelationships between them. But things have been changing. I mean, carrier-grade NAT is now just everywhere, and NATs are ubiquitous at home. So this glib statement, addresses are unique, well, that's not true, because we're all using Net 10, we're all using RFC 1918. And if you're looking at things like Lisp, which is actually breaking the model of name to addresses and saying, wait. These addresses, they're actually 2 separate things. They're a locator and an identity. How about if we tore those in half? How about if we explicitly understand them as 2 separate qualities? So there are things on the table that are kind of changing things here. Okay, so BGP self-manages. You guys run it. I don't have much to do with that. DNS name self-manage. ICANN runs that. I don't have much to do with that. The RIR system is totally self-managed. It's about community-led consensus decisions. But we have to ask ourselves how well we're doing. How do you go about measuring how well you're doing in this space? How's the policy going? How applicable are the decisions that we're taking about this stuff? So if I take a specific example, 6, you would actually stand here and say this is not going well because we never meant to be here. We thought all along we were going to do a migration that would get us out of this mess with addresses, and we haven't got where we wanted to be. Is there a laser on this? Yes. So this is the global address pool, and this section up the top here is the Class E addresses that we can never give out because we were stupid enough to mark them as reserved in an RFC, and we can't unreserve them. There are 3 lines of code in a large number of systems out there that say, if Class C address mask matches, drop this packet. Juniper actually did do a change because apparently some cloud service people want to use those addresses to do deployments, but functionally they're extremely hard to deploy. There was a quite nice move by Cisco to talk about using them, but that also failed at the gate of getting published. So in this address map, the early adopters did a really amazingly good job of consuming address. That's the startup phase, the academics, the people who realize there's something happening here. Up to about 94, 95, things look pretty smooth. But we realized that we were going to run out. So the trajectory was looking really tragic at this point. We'd have hit the limit sometime around 2006. And the RIR system, in effect, is a way to reduce that, to reduce the consumption rate by stopping using fixed size blocks and use an adaptive mechanism where you say what you want and we try to give you something that matches. So the trajectory got changed. Success! Policies worked. But then we get to this point. So this is the worst place in the world to be. because this much addressing has to supply all the future innovation that the world is ever going to want in IPv4. We've burnt all the rest. There ain't no more, buddies. So if you want to put some new ideas out there, you've got to live in a totally constrained environment. Well, that's not very good because we've got a lot of devices to connect. So clearly 6 is the answer. But we've overachieved. We've extended the life. So how are we actually doing in 6? And that then puts all these questions on the table about the qualities of 6 and how 6 is working. And this is the motivation for why we're doing the measurement. Okay, so the trick is we ask users to fetch web resources, and their names which go to a 4 only, or a dual stack, or a 6 only, and we have all these other variations to capture other qualities. And those names, they're unique. No one should ever see the same name twice in this experiment. We use wildcard DNS in a particular way to do that. And it lets us correlate all the measurements that we pass out. So there's a fairly classic way you go with doing measurements. You start by measuring yourself, and we did this. We put measurements on our website, and we got the most fantastic V6 uptake rates imaginable. Because you guys, you've all done 6 in your own networks, right? Your core is 6 connected. So when you come to us, the registries, to say, please, can I have some more addresses? You're using a dual stack network. So we were putting these numbers out saying, yes, V6 has worked. We've got amazing coverage. We were measuring the core of the network. So then we started to do placements with people we knew. Games.on.net, this one. That's a website in Australia on Internode that's a dual stack ISP. But the thing is, the gaming community in the Southern Hemisphere use that to discover, I'm not an avid gamer, but I believe there is a thing called a low ping bastard. And this is where you go to find the low ping bastards in the Southern Hemisphere. The other thing about those people is their website. I mean, do any of you do web design? Because the asset count, I mean, like these guys, they have 200 individual assets on their website. Who is going to notice 5 more doing measurements, right? So this other one, this one was really funny. I don't exactly know where it got placed, but I think it was on the page that senior academics go to look at when they're checking their retirement plans. We got a lot of hits all through Janet, but the problem basically is these were deeply skewed samples. And so we had an oversampling issue. So we had to find a way to measure everything. We're hunting how to measure everything. And there is somebody who's very good at seeing everything that goes on out there. We thought, okay, let's find a way to buy this off Google. So we found a way to tune Google advertising to let us put a flash advert in Google, but say, don't pay for clicks, just pay for impressions. And we tuned it to a point where we were able to get a phenomenal number, 1 million impressions a day, 1 million impressions a day out of this thing. So there's this question, are we getting unique IPs? Okay, just before I go there, this is what a typical experiment sequence looks like. So you can see that there's a fairly long string that's encoding an experiment number for an identity, time in seconds since the epoch, a week since an epoch that we invented of ourselves, a version, and then these bits here encode dual stack DNS, dual stack transport, DNS on 4, dual stack transport, DNS on 6, dual stack transport. These two, actually these 4, they're doing weird tricks in DNSSEC, so they're trying to find out what you do if you're given a lie in DNSSEC. And then at the bottom, we have a trick that encodes the thing as a result. So you ask for one last fetch of a pixel, and that encodes to us the results of everything we've seen from you. So Google do this placement trick. They want to show our ads, right? And they start the billing day, tum-ty-tum-ty-tum. They get halfway through the day, and they think, oh, God, we haven't shown the ad at all. So they absolutely saturate the network and spend all our money. And they think, shit, that wasn't any good. And they back off and they try again, smooth it out a bit. So the second day, they do a little better. You can see they've run out with all the money by 4 o'clock. That wasn't so cool. But they do, their model is really quite amazing. You can see their model adapting as they tune the placement. Did something weird there. But they wind up with a really quite consistent placement rate. We actually decided that wasn't good, so we split it into chunks of like 4 hours. And at launch, that was unbelievably noisy. We were getting spikes of like 7,000 a second, but then we reworked, and we're getting a lovely flat deployment rate out of these guys. And we can actually see the deployment rate. This line here, the purpley one, that's a JavaScript collection method, and it's starting to head towards an asymptote. It's flattening off. It actually does go out to a flat point. But the measurement from Google is just pretty much a straight line. It is phenomenal. Very, very good at giving us unique IPs. Success, mission accomplished, lots and lots of talks. Okay, where are the IPs? So we did a table of where all the IPs are that we capture. Hang on a mo. This is the ranking by internet population that the ITU publish. And that, well, that's how many we agreed were actually in the top 20. So we got half right. But the only one we got right in its actual position was China. So we have a really severe problem with skewed, the way we're getting ads. And there's a reason for this. Google really wants our money. And in the end, if it can show our ad to 200,000 people in Indonesia and get our money, they're going to do that. So we guarantee unique eyeballs, yes. We guarantee unique eyeballs in developed Western economies. No, you didn't pay enough for that. So we have done an adjustment where we actually factor out the relative population. We don't think any of the other people who are doing numbers in V6 uptake have done this. And so we are recording fairly consistently a trend line. Now, I agree, this is noisy, very noisy, but in trend terms, we're getting the same kind of behavior as Google do. But Google are measuring world uptake at about 4.5% to 5%. We see it about 2% lower, and we suspect it's a population thing that we're adjusting for and they're not. There's another problem we have. There are some quite large providers who deliberately do split ASN routing. Time Warner, for instance, have 12 discrete ASs that they use to do their regions. And we can see quite a lot of them. I think we see 9. And we can tell from this that they've actually done a different amount of deployment of V6. We're quite confident from talking with Lee Howard, their engineer, that he's deliberately going around state by state doing a rolling deploy. So if I put up there a one-line number for Time Warner, that doesn't actually accurately reflect what they're doing. Got to think about that. So this is another problem. These are the guys who are doing worldwide routing using one AS. Not to pick on Martin Levy, but there's Hurricane Electric, and they're routing to over 14 economies from that one AS number. So clearly, again, if we ascribe anything we see in V6 terms to these ASs, we're going to wind up misrepresenting what's going on because they're not in one single economy. By the way, I don't know who Colt are, but that's a British AS that's in a fairly large number of locations, so it's happening everywhere. So we've got this idea that we can identify who people are and we can map them, and we've been looking into things like our own Whois registry on where addresses are registered, and we also compare with MaxMind, but there is actually a really big problem emerging here. And that is that our sense of what an registration economy is quite different to an engineer. So when you come to us and say, give me address now, we say, fine, where are you? You say, I'm in Europe. But then you go and flog them to Asia because that's where you actually are making your money. You sell to customers in Asia. You route in Asia. You don't necessarily tell us that you've deployed the addresses in Asia. So the whole thing about what economy is this address is kind of confused. MaxMind in particular has done a really amazing job of identifying that various things are being used for VPNs. I believe there's a show about dragons and things that people want to watch that involves using VPNs. So what address is that, what economy is it, is getting quite confusing. We can't measure anyone on mobiles because we're using Flash. That's a bit of a problem. We can't measure people who've got ad block. Well, that's a good thing because you really wouldn't want to measure them if they don't want to be measured. We think we're going to have to move up the food chain into HTML5, and that's going to be quite interesting. We're midway through the technique. Okay, so let's get to the numbers. So this is the URL where we publish everything we're seeing using the UN regions. So the stands are in Asia according to the UN, the stands are with RIPE according to the RIRs. And we think we've identified 4 trends, and I really hope I'm not offending anyone if I put that first one up there. So this is the current view of V6 in the United Kingdom, and you can see that it's at a fairly low rate in effective end user penetration terms. We really don't think it's happening. So this is China, where we also don't think it's happening, but we don't know because we can't measure properly. It's been put to me that these holes may represent academic term time and holidays, and that what we may be doing is measuring the Chinese university system, but it's just impossible to know with China because of the firewall. This is France, where they did a deployment in Proxad using a transition technology called 6RD. They were very early adopters, and you can see that that's effectively peaked. There are some points where things go high, but to all intents and purposes, they've reached their saturation level. Okay, in America, it is totally on. It's happening. I mean, this is just totally out of scale. And in Malaysia, interesting late starter, doing very well. Germany, doing very well. Belgium, plucky little Belgium. So, how come Belgium did so well? Well, if you look at Belgium, you can see that the top 3 or 4 here have got some phenomenally high penetration levels, and then it suddenly drops away. But the thing is, they are basically the top 3 ISPs in Belgium. Okay, this is the listing for the United Kingdom. And I believe we had a speaker from Andrews and Arnold earlier in the day. Second place at 36.04%. I don't know who Rackspace is. I'm assuming they are a company that provides Rackspace. As you can see, there's a varied degree of deployment there. So, okay, let's resort this by the sample count. Now the story gets a little sadder. So, it's not so impressive. We've got Janet at 5%. That's all those academics looking to retire. And we've got Telecity down here, but the rest of the field is looking really empty. Now, if you look at that sample set, that's a fairly respectable set of numbers. I mean, this is not just some phantom from 1 or 2 samples. We really are seeing a lot of end users. But there's something else here, because if we take this model we've got of how many we saw, I mean, I don't know your market, right? I'm not in the UK anymore. I moved out 30 years ago. Is this hugely implausible as an approximate ranking of market share? I mean, is it totally out of order? I don't know. Is Virgin really top? Is BT second? I wouldn't know. But I would imagine it's not that they're actually 25 and 26, right? They really are in the top 5. That would be plausible. So, random samples, little old me, down in Brisbane, we've successfully managed to get an approximation of your market share. And we think we've got this worldwide. So this is America, and you'll see here the effect of Time Warner Cable doing their split, because they are actually up in the top 5 set. I mean, they're just about to join Comcast if the government will let them. But because they route by separate ASs, they appear to us as a split set. But I've spoken with a few people, and this is approximately accurate for things. You will also notice that MCI, now there's a company that I don't think has actually been in the business of directly selling service for a very long time. So this is a bit of the data quality problem we've got. This is the economy I live in, and this is a huge example of it, because that number 3 position Microplex, that's Optus. That's Cable and Wireless Optus. They've just never bothered to rename their AS in the WHOIS. Bit surprising there that TPG is in the 2nd rank. They've just swallowed Internode, who were swallowed by IINet. So in fact, we've had concentration at the top set down to 3 major providers. This is fairly accurate for market share, by the way, in my economy. And we do the same thing in DNSSEC. So this is the UK for DNSSEC, and the numbers are actually not bad. 6 is pretty good. Do you notice there's a blue and a red line there? The blue, the validating in DNSSEC, matches pretty closely the number of people who are using Google. So what's going on here is that some of the ISPs have been putting Google behind their DNS. And if you do, you come out really high. Now these are really quite nice rankings. I mean, this is really quite good. And if I resort this one by market share, well, the top set aren't stunning there, but at least we've got some high numbers coming in. Interesting how low Janet is. You would have thought the academics would have done a bit better. But it's actually not looking too bad. This is America by comparison, and you'll see that there's actually quite a big separation of using Google and validating. So unlike the UK, where it's effectively synonymous, if you use Google, you validate. In the States, people are doing it for themselves. And we've got a rank in there. We've got a map of how it's going in Europe. Sweden has had a national program that's been fairly aggressive, and so they show up top of all the economies, and they don't use Google. The red is not meant to mean doing badly. It's just the automatic axis color scaling. There's the rankings for the European economies with Sweden up the top, and you can see very low rates of Google providing that. So we can answer quite a lot of different questions with this thing. We found ways to drag out tunnels. We've been looking at relative RTTs. Any of you noticed a bit of press lately about 6 is faster than 4 for some people? I'm fascinated by that. I have a feeling it's going to be people who are on a native dual stack 6 with 4 embedded inside. But someone else said to me, no, George, there is an explanation, and it's money, because packets route by profit, not by optimal speed. And if it's profitable to route 4 on a slow network, they will. So it's possible there really are 6 and 4 relativities where 6 is better. I'm skeptical because I've lived on dual stack for a long time, and I've got to say from the bottom of the planet, it all looks the same. But I thought it was interesting. We do a bunch of DNS stuff, been testing big packet things. So we think we've got a nice measurement rig. We do know we got some bias. But there's this thing about the policy, why we were doing it in the first place. And there's this question that's kind of arising. We know there's no shortage of address out there. You guys have got it. And we know that it's remarkably widely deployed. I doubt if anyone now is actually more than 1 AS away from a decent 6 source. It's the CPE. We know it's the CPE. And if you do the rough sums, let's say it's going to cost $50 to sort it out in a house, and you guys have got 40 million customers, that's $800 million that's got to be spent. And no one wants to do it. So I invoke this nasty word here that nobody seems to like. And whenever I put this, there's usually a lot of booing in the audience. But there's this word too. And I do want to point out that there are things people can do in the regulatory sphere that would encourage this kind of thing. They did it for the digital TV switchover. So it's not impossible that there could be an industry-neutral move to try and fix things here. I'm pretty worried about this because I really like the net because it's the same everywhere. But that is not true because we're getting segmenting by investment, economic conditions, policies. This one, particularly in Australia, is a very, very real risk. We are looking at something that's been quite diverse, potentially coming back down to a far smaller number of providers. And if we don't want to have 2-tier networks, the bottom line is we're probably going to have N-tier, lots of different qualities of what the network really is, and I don't think we want to be here. CGN's ubiquitous, it's incredibly cheap to deploy, there are no visible consequences if you do it the right way, and we're just about to run out of addresses in America, so none of us really know what's going on here. These are the people who've been helping us, so I'd like to thank. And I think this is a lot of fun. But wait, there's more. I need you. We all need you. Actually, the people who need you is not me, but it's this mob, Cryptech, who realised in the wake of Snowden that we actually had a huge problem because instantly trust in security in the global network just went out the window. There is absolutely no reason why anyone should trust any hardware that is implementing cryptography, any provision of service anymore. Why would you? They lied to us. They lied to us. The National Standards Bureau in America said we will always stand up for high quality crypto, and they lied to us. So a bunch of people have been working on a completely independently designed and audited FPGA implementation of what ultimately could be an HSM. And they've reached a point where they actually have a functioning system. The Nirvana board is a microcomputer with an attached FPGA, and they're able to put their Verilog VHDL onto this device. Now that is not an HSM. I mean, you can walk all over this thing. It's not physically secure, but they have developed a source of random noise that's really quite important for secure keygen, and they've tested it using the recognized mechanisms, passed, and they're working on the potting and the tamper protection, but they're running out of money. And they badly need diverse money because they do not want to be captured by one single source of funding. So I know you hate calls for cash, but if you work for a company that cares about privacy on the network, please think about ponying up some money and talk to these guys because they really badly need the help. That's me.
Okay, any questions for George?
I'm doing this again at Links, so if you want to come and throw mud at me, you can do it in London.
While you're in the hemisphere, yeah.
Yep.
Okay, no questions.
Okay.
No questions, I heard
Yeah, that's what I thought.
We've got Adrian here.
It's Adrian again. Your point about CPE is a very good one, and it's one I've raised on talks about IP6 in here in Links for many years. I think actually we are getting to the stage where the CPE is starting to support IP6 now at last.
Yes.
Largely because of just the cycle time of hardware development
Yes.
and new software.
I regard CPE as functionally the same as white goods. When we bought one, it was a purchase of low dollar value, but emotionally my partner said, well, that's the last time I'm buying one of these bloody boxes, and it sat there for 5 years. And because it's DSL, those transistors heat up and eventually the caps blew and I went and bought another, and she did, well,
Exactly.
why didn't it last 20 years? And I think that's how people feel. So yeah, there's a huge long tail of kit. I was really disappointed when DOCSIS 3 came out that it was not like an automatic. It was in the profile, but it wasn't an automatic given that the thing would sit there and do DHCP PD. I believe 3.1, however, is much more 6 friendly. So in cable, much though I hate it, there's a possibility. Because with cable, you don't buy your own so much. You tend to get factory installed and centrally managed. Cable's going to be a deal. But ADSL, I don't know about this economy, but in ours and in New Zealand, it's bring your own. And that's a nightmare of provisioning to get right.
I'm just saying in the certainly what our experience in the UK is the routers you can now buy are
They have the tick
fine.
box and they will work if the provider turns it
And
on.
the old routers are finally dying out.
Well, I think we should make the signal more flaky to make the capacitors die so they die out quicker.
Okay, Tim.
Don't send me a curly one, Tim. I won't be able to answer it.
We're going to talk about bowling between Australians and yes. So
Underarm bowling, mate.
So I forgot what I was going to ask now. Oh yeah. So I think the first one's a sort of a comment I'd heard from someone, sort of a Belgian guy that's into IPv6 security, that the reason the Belgian ISPs deployed was sort of a government push based on making users more accountable and traceable than if they were using CGN.
Isn't that a horribly delicious moment? That the thing that we don't want them to do, which is to start snooping, is easier to do in 6. So that's pretty bad. But I still believe in 6, even though that might be true. If that's Eric that you were speaking with, no?
It may be.
Because Eric told me that they put a rule out in Belgium, you can't have more than 30 customers behind one IP in the CGN. And I know
I think it was
in
16 actually. But
yeah, and I know in our region it's up in the thousands. We have seen the binding time in the CGN down below 10 seconds, 5 seconds, and they're another person.
Yeah.
So there's a phenomenal rate of churn in our economy. The Belgians don't like that.
Yeah. So that's what I'd heard, and it's very plausible.
Yeah, but doesn't it put us in an odd spot, right? That
Yeah.
they're going to be able to track us better in 6? Yay, go 6! Not sure about that one.
And on that bombshell, yeah. So the other question was about the CPEs. I think it does seem, I don't want to sort of speak for Sky, but it does seem that Sky are going to be the first UK broadband provider to do a reasonably significant deployment, but they build their own CPEs essentially. It's taken them time, I believe, to get right with that, but they hope to have a couple of 100,000 people with V6 by the end
I
of
would
the year.
really like to see if we can track that. That would be bloody fascinating. So power to their elbow.
But yeah,
Except for the fact that I like the BBC better, but power to their elbow.
yeah, but the BBC don't give you broadband, or V6 on iPlayer.
No. Funny that.
So I've forgotten what the question was now. I've been totally...
Achievement unlocked.
There's a couple of statements and I've forgotten the question. I'll hand the microphone back to Brian and crawl back under the table.
I'm out of here. See ya.
Okay, thank you, George.